Our vSwitch policies would fall under 3 categories. So in this module, we'll cover security policies for vSwitch. Whilst in a separate module, we'll cover traffic shaping and teaming and failover policies. So network policies are configured at the standard vSwitch level, at the port group level, or at the distributed port group level. With the policies that are configured at the port group level overriding the vSwitch level configurations. Okay. Policies that are set at the vSwitch level would apply to all ports on that particular vSwitch, unless they are specifically overwritten by policies that are applied at the port group level. So this would be ideal in cases where we would want to set a strong policy at the vSwitch level, but a weaker policy at the port group level, for example. An example of this is if we are doing a port group configuration for testing and development virtual machines. That's an ideal use case where you'd want to use this setting. It should be noted that with distributed vSwitches, which we'll discuss later in a separate module. So in distributed vSwitches, the security policies or the network policies are applied only at the distributed port group level and not at the distributed vSwitch level like standard vSwitch level. Okay. So in this section, we would discuss the security policies. We'll discuss and demonstrate this. The security policy would fall under promiscuous mode, MAC address changes, and forged transmit. So let me pull up my vSphere web client here so we could have a look at these settings. I have my vSphere client here. So we'll go into the host and cluster view. Let's work with one of our hosts here. We'll select host ESXi1. If we go under manage and then networking, we'll see our vSwitch here. This is where we would configure the setting for the vSwitch as a whole. So we come to our host, manage networking, vSwitch. If I was to click on this edit setting or the pencil icon here, I would have the options to configure the different policies for this vSwitch. As I mentioned, we have 3 different settings. We have the security setting, we have traffic shaping setting, and then we have the teaming and failover settings. All right. In this module, we'll deal with the security settings. All right. This is where we'll configure the settings as a whole for the vSwitch. What we could also do is select one of the individual port group within this vSwitch and click on this pencil icon here. So this would allow us to manage the setting per port group on that vSwitch, which is vSwitch 0 in this case. So we'll talk about override settings just now, but for now, we could select these settings here and override the setting at the vSwitch level. All right. So let me get back at the vSwitch level here. So for security settings, we have 3 different options here, or 3 different configuration. We have promiscuous mode, MAC address changes, and forged transmit. Promiscuous mode. This is set to default. Sorry, this is set to reject by default. um, on our vSphere standard switches. On distributed switches, it is set to reject also, and it would prevent VNIC from monitoring traffic submitted through a vSwitch. If we set this to accept, it would allow a virtual machine with a protocol analyzer to receive all frames. So this is a valid use case where we may have an intrusion detection system to scan network traffic from other VNICs. Let's say for patterns, for example. This can be configured overall on the vSwitch or on a particular port group, as I mentioned previously. So rather than implementing this at the port group levels for all VM in that port group, we would want to just create a dedicated port group on this vSwitch and place our intrusion detection system there. So in this case, the intrusion detection system would have the same VLAN ID, but promiscuous mode would be set to accept rather than to reject. Okay, so that's if we want to override the setting. It should be noted too, setting or allowing promiscuous mode in our virtualized environment, it can compromise the security of that environment, where we may have a hacker that try to capture network traffic other than from his or her own system. Next in our list here, we have MAC address changes. This is set to accept by default in standard vSwitches and reject on distributed vSwitches. Okay, so it allows for the receiving of frames even though the MAC address has changed. So the MAC address changes setting, it would allow us to receive frame even though the different initial and effective MAC address has changed. We have to be careful with setting this MAC address change to reject. Okay. If this is set to reject, we could have someone impersonate a node or gain access to our environment by spoofing its MAC address. All right. Change MAC address in this case means the initial and the effective MAC addresses are different. All right. So let's just recap or recall. Each VNIC on a virtual machine would have its own MAC address that is assigned by VMware and is generated automatically and stored with that VM. Okay, so by default, once we create a virtual machine, it's automatically assigned a MAC address there. We could always change that or go in the VMX file and modify that too. So that's called the initial MAC address. All right. Let's identify this setting in our vSphere web client, the MAC address, the initial MAC address. So I'll just cancel out this for now. If I was to come in one of my virtual machine here, let's just go to this vCenter, and I go to Edit Settings. If I go to my network adapter and I expand this out here, this is my initial MAC address, and by default it's automatically assigned. All right. So let's go ahead and just add another network adapter here to see how we could modify the actual MAC address on this. All right, so I have NIC3 here. By default, the MAC address is automatically assigned, but we could also manually specify this MAC address. This is the VMware organization unique identifier for this MAC address. We could add in or customize this, but by default it's set to automatic. But this is our initial MAC address here. All right. What we could also do is view that MAC address in our VMX file. So let me just pull up WinSCP here. I have this running. So I just browsed to the VM files for this particular virtual machine. If we were to edit this VMX file, and we'll see at the bottom here, we have our MAC address pertaining to this virtual machine. All right. We have one here because we have 2 NICs deployed on this, and one here. All right. So this is the initial MAC address for a virtual machine. There is also the effective MAC address. So the effective MAC address, this is the MAC address that is configured by the guest OS for communication. So by default, the initial MAC address that is automatically assigned for that VM and the initial MAC address, those are the same. Okay, so we could change the guest OS MAC address. Okay, so I'll just show you guys in Windows Server how we could go about changing the guest OS MAC address there. So let me just pull up Windows Server here. All right. If you were to go into Network and Sharing Center, come under Change Adapter Settings, Status, and then we could view the effective MAC address here. Okay. What we could do is make this effective MAC address different from the initial MAC address. All right. If you were to go into properties for this interface and come under configure. Under configure, if we were to go to advanced, come down in advanced under logically administer address here. So this is where we could make this MAC address different from our initial MAC address that was assigned to this VM. Okay. So let me just minimize this and go back to our setting here. So as we can see, we could have changed the MAC address in the guest OS. We do not have the ability to deny that change in the guest OS. But what we do have is the ability to deny traffic once this MAC address is changed in our guest OS. So this is exactly what the MAC address changes policy does. It allows us, or it allows the initial MAC address that is configured in the VMX file. It allows that to be different from the effective MAC address, which is configured in the guest OS. All right. So MAC address changes is concerned with incoming traffic. So incoming traffic going from our vSwitch towards the VM. Okay. So this is where this policy would differ from force transmit, which we'll discuss next. All right. So we look at promiscuous mode. By default, it's set to reject. MAC address changes by default set to accept in our standard vSwitch. And now force transmit. So force transmit, this is set to accept by default in vSphere standard or standard vSphere switches, and reject on distributed vSwitches. Okay. It allows for the sending of frames force transmit, it allows for the sending of frames from a virtual machine, even though the MAC address has changed. So just like we discussed just now, even though the initial and MAC address, the effective MAC addresses are different, if this setting is configured to reject, all right, if you were to set this to reject, so basically if we set this to reject and our initial and effective MAC addresses are different, traffic would eventually be dropped. All right. So force transmit, it deals with outgoing traffic or traffic passing from the VM to the vSwitch in comparison to MAC address changes, which focus on incoming traffic. All right. So as I mentioned previously too, we could set this at the vSwitch level or come under one of our port group. We could create a separate port group for our intrusion detection system. Let's say this is the port group. We would edit the setting for that, and we could override these settings for our standard vSwitch in here.